Hey, what's up, everyone? This is Tim here with TestDemy. We're back live and direct. First of all, I want to just give everyone an update. I haven't been able to make a lot of videos lately. As some of you know, if you've been following the news, there's been a severe, devastating hurricane out here in Houston. So a lot of us were kind of affected, so it kind of slowed down the production. But first of all, I want to hope everyone that's doing well out there in Houston or the surrounding areas, anywhere in Texas, as a matter of fact, or Louisiana, or if you're out in India or out there in Nigeria where you probably got hit with floods. Just want to wish everybody the best, and want to make sure everyone just prays for everyone out there. Everyone is safe. Hope you'll be able to get back on your feet. But just want to give you an update for where we were. The hurricane kind of slowed things down, but we're back. We had to kind of take about a week off or so, but we're back. We're gonna, jump into this and keep the video rolling. All right, let's go, baby. All right, so for today, we're going to look at, as you guys can see, we're going to look at tutorial 27, where we left off last time for tutorial 25. We looked at how to write to files. In tutorial 26, we looked at how to read from files. So in this case, we're going to now move on to the next level of when it comes to programming. That's called the object-oriented programming. And why this is important is because a lot of jobs out there, they're looking for automation developers or test automation engineers. They're looking for you to have some kind of experience when it comes to object-oriented programming. So I'm going to try my best to introduce you guys to a lot of these concepts, get you going so you can be able to understand how object-oriented works, begin to write some code, get good, and get your first job as an automation engineer. You have a good understanding of object-oriented programming. Just like I mentioned earlier, if you guys haven't seen one of my videos, I did a video on how to get started in as a software automation engineer. And one of the great things we mentioned on there um, was the fact that a lot of the companies, again, like I mentioned, were looking for automation developers. And one of the object-oriented programming languages out there is Python. Is an object-oriented programming language. You have Java is object. Correct my notes. There's an object-oriented programming language. You have C Sharp. You have Ruby, and you have a variety of, to an extent, JavaScript also is an object-oriented programming language. So you have a variety of great object-oriented programming language, and your ability to understand these concepts, know how to program or write automation test scripts or code with the OOP, which is the short form for object-oriented programming, is going to make you a much more sought-after automation developer. All right, so let's jump into it, right? You have to understand when you're looking at object-oriented programming, when it comes to Python, everything in Python is it's an object, right? So when you're looking at that, we've looked at a lot of things that are built on the object-oriented platform or theory. We've been doing all of our programming, right? So the question you might have now is why uh, is object-oriented programming important, and what is it about it that's crucial? One thing you have to keep in mind, which we're going to look at here as we begin to write some code, is that with object-oriented programming, it kind of helps you reuse a lot of your code, right? And when you're talking about reusing your code, it helps you reduce the amount of time you have to develop code or keep rewriting the same kind of code. You can just reuse that same code by calling objects or creating objects, or in other words, it's called instantiating an object from the classes you've already created. So it helps you reuse your code, develop less code. It's easier to maintain your code. Another great advantage of object-oriented programming, or OOP, is that it helps your code be more modular. So you can write modular code, right? In other words, you help break your problems in your code into modular problems as opposed to one large chunk of code. You can modularize it, right? Kind of break it out into little chunk-sized problems and kind of write more efficient coding from that. So you guys have been looking at functional programming in the past, so now we're going to jump in, like I mentioned, into object-oriented programming. And one of the first concepts you want to look at when you're looking at object-oriented programming, everyone, is the idea behind classes and objects. So to make it more simple, what helped me get going is you can always look at a class as a blueprint or a template. For example, if a builder wants to build a home, they have a blueprint, right? The design, the schematic, the layout, right? The architecture, the blueprint, right? Which is the home. Well, from this blueprint, they can build a lot of homes from it, right? You can build a home A, home B, different kind of designs, but there's a blueprint, right? So the class is considered like, you can look at the class like the blueprint, and you can look at the object, the actual physical object or the physical thing that was designed from their blueprint. So you have a blueprint and you have an actual house. an actual house that was built, or an apartment complex that was built from their blueprint. Right. So when you want to write classes in Python here, as far as this OOP language is concerned, you want to start off with the class keyword. We looked at keywords in the past. So when you want to define or create a class in Python, you start off with the class keyword. You write class, do space, and what's used in Python for the naming convention, you want to use capital letters, right? If you guys remember variables, we use lowercase letters and we use the underscore. But when you come to classes in OOP, you want to use capital letters and you want to use camel case. So for example, you can say this is, you see that uppercase I here? This is, and I can say class, right? So those are all different letters, right? And you have the colon, pardon me, at the end. But in this case, we're not going to have anything too long. We're just going to create a simple class called computers, right? So I want to show you guys something pretty cool. So we're going to create a class called computers. You can call this whatever you want. It's just a name. But again, the main thing is you want to make sure it starts with an uppercase, right? And if you have more than one letter, you just, you just use the next letters, use uppercase, like the camel case, okay? So the first thing you want to do is you want to initialize your class in Python, right? And Python uses what's called the init method. So what you want to do is, you guys looked at other, when we defined functions in the past, when we're doing functional programming. Now, and I mentioned this earlier in some earlier videos, when you want to create a function, right, within a class, or in this case, we're defining a function within a class, they're called methods. So it's not really necessarily called a function, although it is functional, but you actually it's going to be called a method. So what you want to do is this is called a method. You use the same def, which is to define a function, but in this case, again, it's a method. So you can call this, you want to use the init method, right? So you use two underscores, underscore, underscore. So Windows, that's shift and the minus sign, hit it twice. Underscore, it's going to use the init, and you can see right here, init, init underscore underscore, and it has the self, and we're going to talk about that in a little bit. This is pretty much the convention when you want to do this. This can be called anything, but the self is just the first parameter that you pass, or the attribute that's passed to the initialize method, and how you initialize your first method within your class. Okay, all right. So when we create that initialize method, whenever you have this underscore underscore, that's called a magic method within Python. And with a magic method, all that pretty much means essentially you want to create a special kind of method. And in this case, we're creating an object. So it's just it's used for special purposes. Okay. And again, like I mentioned, self is the first method, right? So if we call the self method here, a lot of times what we want to do is you can pass other. They're called the attributes. For example, if you have a computer, right? What are some attributes of the computer, right? One attribute might be a name, right? The computer might have a name. Another thing might be a color, right, of the computer, just a physical color of the computer. What is another attribute of a computer? Another one is the OS, right? We can just say, we can just call this the operating, we can just say operating system, right? Right, we can call that the operating system. That's another, that can be another, another attribute for computers. So let's just use that for now. So we're going to have name, color, operating system, right? Those are some of the attributes, right? But again, the self method it can be called anything else, but for Python convention, a lot of times it's just called the self. And self is normally the default first attribute that's passed. It's passed automatically by Python. So as you notice, when I created the init method here to initialize this this class that we created, they created the self by default. So always keep that in mind. So the way we go ahead and create this is we want to do self dot, and you're going to do dot name. So these are the actual attributes, right, that you're passing, and you're going to call this name, right? You're going to do self dot, and again, you can call this anything, but again, for simplicity purposes, since we went ahead and passed these arguments, we're actually going to use them here. So we're going to say self dot color, right, and we're going to say color, okay. Next, we're going to do self dot operating system, right? And we're going to say operating underscore system, okay? And we're going to say, we're going to call this operating system, okay? And you can see it's the P for the parameters, okay? And just kind of break up a few things here. So this first one is, this is called, all right, this is how you create a new class in Python, okay? This is the class, all right? These here, again, remember, this is how you comment out your code, okay? So these are your attributes. So you guys can understand. These are called attributes. These are called the instance variables. Let's just call them instant variables, right? Or attributes. Instance variables. Okay. These are your instant variables, or you can say attributes. Okay. So you guys just kind of understand the different. Because I want to introduce you guys to a lot of concepts, right? On this first one, excuse me. Okay, attributes. And these are the actual attributes here: name, color, operating system. So we've actually defined the first method, which is the init method, and we pass some variables or some variables or attributes to it for a computer. A computer can have a name, it can have a color, it can have an operating system, right? So what you want to do now is one of the other concepts you want to introduce is the concept of objects. Like I mentioned earlier, everything in Python is actually considered an object, but there's something called instantiation, right? So whenever you create, so the computers in this case, right? This is considered the blueprint, right? So the blueprint is you're gonna have each computer have a name, color, operating system. Again, for this, you can keep on defining as many attributes as you want, right? But we're just gonna, for the purposes of this example, want to keep it simple. Um, so the next thing is you have the computer, which is the template or your blueprint. Now the physical item that was created from that class is considered objects. And what you do is you instantiate that class, right, by creating an object. So whenever you do an instantiation of a class, it actually means an object is created. So and you can say the word instantiate or object. You can look at them as interchangeable actual words when it comes to operating, object-oriented programming. So we're going to call this first object. We're going to instantiate the class. It's going to be called Apple. For example, Apple computers. And what we're going to do here, we're just going to, pass in the actual class, right? So you're going to say it's going to be inherited from that actual class, right? The computer's class, right? So here, if you notice there's an underscore here, what that is saying, it wants us to pass in some of the variables, right? The variables we defined here. And again, the self is automatically passed here, so we don't have to worry about it. But if you notice, it's calling out three parameters here, right? You see it says color unfilled, name unfilled, and operating system unfilled. So we have to actually pass those actual attributes to the object. So what is the physical device or item we're creating, right? So we're going to call the computer. The name, again, the name, self.name is going to be called Apple computers. All right. The color is going to be, we're going to just say green. Call it, you can, whatever you want, it's fine. And the operating system, we're going to call it, uh, uh, actually, I should call this, let me call this Macintosh. Right? Let's just call this Macintosh, right? That's fine. You can just call this iOS, right? It doesn't really matter. It can be an iPhone, whatever. You can just call this iOS, right? So it doesn't really matter. So what we want to do is now we want to go ahead and print this. And what we can do is we can just do Apple. What we can do is we can just go ahead and print this object because now Apple is an object. So this is how you instantiate. So it's an instance of a class. So instantiate is an instance of a class. This is how you instantiate a class, right? This is an object. Creating an object. So that's how you instantiate a class, okay? So we can go ahead and print Apple. And you're going to notice if we instantiate this, when we instantiate this class, which is the Apple object, and we go ahead and print this, you're going to notice here, it didn't really print out actual code. What it actually printed out, it printed out this location in memory. So this location in memory, it says main underscore underscore main underscore underscore dot computers object at, and it shows the location in memory. And again, if you're following the same example, yours might show a different location in your memory. So what that's pretty much saying is this Apple here is printing out this Apple, right, which is this object. But this object really is this self. This is the self here. You can really say this is actually really self. That's what it's actually printing out. So that's actually the location in memory, which is self, right? So if you want to actually print out the actual more specific attribute, you're going to have to pass the actual attribute name. So let's go ahead and again call this Apple. Again, that's the self that's being passed there. That's what you're seeing printed out. So if you want to actually print out the actual attribute, you actually, like I mentioned, have to pass the actual parameters or attributes specifically. So in this case, we're going to do print that name, right? So if I go ahead and print that, you're going to notice it's going to print out Macintosh, right? You see that? So it printed out Macintosh because we passed in the self.name here. We printed out, so this is really self. You can say this is really self.name, right? Self.name, right? That's really what it's doing here, which is actually what is printed out here. All right, so let's go ahead and change this back. So we do Apple.name, so you can print out Macintosh. So that's the name of our object. The actual computer, that was the name of the computer. So what's the color of our computer? So we're going to do, you can see here, you can see these functions, right? That color, right? Those are the actual variables. And we can do Apple dot, and we do Apple dot, you can see the operating system, right? And you notice it inherits from this computer class here. So we do operating system, and now it's going to print out not only the name, it's also going to print out the color, and it's also going to print out the operating system. And if you notice here, it printed out Macintosh, which is the name of our computer object. The color of our computer object named Apple is green, and the actual operating system for the computer object the Apple object variable is iOS. So what I wanted to do for this first video introduction to object-oriented programming, I wanted to show you guys how to create a class, define what a class is, some of the advantages of object-oriented programming versus functional programming, which we looked at in the past when we just created DEF functions. But in this case, we're using object-oriented programming because with that, we don't have to actually always retype this code. We can actually just create instances. So again, I can also do this. Also, I can now create another computer called Windows, right? So in this case, again, it inherits from the computers class, right? And in this case, actually, I'm not going to call it Windows. Let's call this HP, right? So that's an HP object, right? And let's go ahead and say this is Hewlett Packard. That's the name of it, Hewlett Packard. Okay. Oops. So Hewlett Packard, and this is gray. Right, and we can just say the operating system that came with this, it can just be Windows. Okay, right, and we can just go ahead and print the same thing here. I'm just going to go ahead and print this out. But as opposed to HP, right, so we're going to print, as opposed to Apple, we're going to call this HP, HP.name. So this is the HP object. So it just shows how, you notice I mentioned earlier in our example how you can reuse code, right? So it just shows how we can just keep reusing the same code as opposed to typing everything from scratch, creating a whole new function and initializing it. You can just keep creating instances. So from this blueprint called computers, we created the Apple computer. Now we're creating an HP computer, right? Or object. So just HP.operating system. You're going to see, right? Let's see here, line 35 in our code, operating system, right? Let's see here, okay. Let's see, what is it complaining about? Okay, I didn't put a comma. There you go. All right, so that should fix it. All right, so there we go. So sometimes it's good to see problems so you guys can know how to work through it. Let's do this so we can make a little demarcation just for everyone else to follow pretty easily. And all right, so we can see our first object, which is the Apple computer, deals with the attributes. And our second object, which is the HP computer, you can see the name was Hewlett Packard, the color was gray, and the operating system was Windows. So let's say we had another computer we created, right? Again, from this computers class. And the next computer, I'm just going to copy this just to make it a little faster here. Pardon me, what happened? All right, so let's go ahead and copy this. So we're going to create another object. And this object is going to be our Dell. Right, well, this is going to be Dell. It's going to be a Dell object, another computer. So this is going to be Dell computers. Let's just call it Dell. And the color here is going to call this is going to be black. These are the attributes. All right, so this operating system here is going to be, let's just call this Unix, right? It can be Red Hat or whatever. It's going to be Unix. And again, we're going to pass the variables that we want to print out here. So this is the great thing about object-oriented programming, right? You don't have to actually use the same code. You can just actually leverage it each time. And we'll go ahead and print it out. And for Dell, you can see Dell computers, the color is black. The operating system is Unix. For HP, Hewlett Packard, the color is gray. It's a Windows operating system. For the Apple computer, it's a Macintosh. The color is green, and it's iOS. So just want to introduce that concept of what a class is. Here you can see the class, which is a blueprint. The objects, which is the actual items that were actually created, physical objects that were created. how you instantiate an object. This is how you instantiate it. When you create the objects, it's instantiated. When you instantiate the class, you create the objects. How you define the method. So we define the init method, which are called and you pass them arguments, which are called the instant variables or the attributes, and go ahead and begin to create your class objects. So that's all we have for this first introduction to object-oriented programming. I know it's a lot, but I want you to practice, create your own objects. You can use a variety of different other examples. But the biggest thing, guys, I want you to practice, practice, practice. And don't forget, we'll see you in the next video. Don't forget to subscribe on the YouTube channel. Go ahead and like this video if you like it. Leave some comments of your own code in here. And also, don't forget, check out TestDemy.com for all the free tutorials that we do have, and I'll see you like always in the next video. One love, stay up, and y'all be safe out there. All right, peace. TestDemy.com. See you soon.